Have you ever wondered what was before the Big Bang? The idea of a beginning has always been a little tricky for philosophers and scientists alike. Even though the Big Bang theory is the prevailing cosmological model for the universe, it doesn't explain what happened before the Big Bang. So let's take a journey back in time and try to find out what was before the Big Bang. A few decades ago, the prevailing scientific theory was that the universe had always existed in much the same way it exists now. This theory, known as the steady-state theory, was eventually replaced by the Big Bang theory. It wasn't long before this new theory led us to a new problem. However, because even though the Big Bang explains how the universe evolved into the state we see now, it doesn't explain what caused the Big Bang in the first place, or what may have come before it. The main evidence against an eternal universe comes from the fact that all galaxies appear to be moving away from each other. If you were to reverse the flow of time, they would all move towards one another until they were all in one place. At this point, they would collapse under their own gravity, causing an event known as the Big Crunch. However, evidence for a beginning also comes from the universe itself. Cosmic microwave background radiation, or CMB, is basically the leftover heat from the Big Bang. It's the oldest light in the universe, and it has an incredibly uniform temperature throughout. This implies that the universe did indeed begin with a hot, dense state known as a singularity. But unfortunately, it does not answer the question of what came before that. There are several attempts at solving this problem, including the infamous oscillating or bouncing universe theories. These theories assume that the Big Bang wasn't the first such event. Instead, our universe is just one of many, with each being separated by a period of no space and no time. However, there are serious problems with this theory. According to this theory, the universe would need to bounce infinitely in order to solve the heat-death problem. That is, since the universe is expanding at an accelerating rate, it will eventually reach a state of maximum entropy, which means it would have to keep on contracting in order to allow for the formation of new stars and galaxies. For this to happen, the theory requires an infinite amount of energy that can't be accounted for. Another issue is the horizon problem. This refers to the fact that the CMB is remarkably homogeneous on all but the largest of scales. In other words, if you look up into space, you can't tell where the edge of the universe is because it keeps going forever. However, according to general relativity, different parts of the universe should have slightly different temperatures since they would have started off as separate entities that didn't interact with each other. The fact that they're all the same temperature tells us that there must have been some interaction between them. But the only thing that could have caused such a large-scale interaction is inflation. To explain, in 1980, Alan Guth proposed a period of exponential expansion immediately following the Big Bang that lasted for a fraction of a second. This solved a lot of problems with the Big Bang theory, including the horizon problem. It also helped explain why there aren't more magnetic fields in space. And it solved the flatness problem, which says that the universe is so spatially flat that it's unlikely that it would have started off in such a state. It's more likely that the universe expanded exponentially, blowing it up to the size we see now. But unfortunately, inflation has its own problems, one of them being that we don't know what caused it. There are a number of hypothetical particles that have been suggested as a cause. These include the hypothetical inflaton particle, the hypothetical scalar field known as quintessence, and the cosmological constant, which is represented by the Greek letter lambda. The simplest explanation would be to attribute it to dark energy, which is already a hypothetical concept, so it doesn't really help us to solve the problem. Luckily, there is another approach we can take: string theory. String theory requires extra dimensions beyond the 4 we experience every day. While these extra dimensions are small, they allow for the possibility of microscopic black holes known as micro-black holes. The idea is that the Big Bang wasn't really a beginning at all, but rather a phase transition similar to water boiling or a magnet flipping its polarity. Just before this phase change, empty space would be filled with these micro-black holes. They would then collapse in a process called Hawking radiation and release an enormous amount of energy. It's possible that this energy could have been what caused the inflationary period and thus the birth of our universe. However, like many other theories, there are some problems here. First, Hawking radiation actually makes black holes evaporate. Since these micro-black holes would have to exist for billions of years before the Big Bang, they would have evaporated long before the universe began. Second, the radiation released from these black holes would be random and uncorrelated. This means that the energy wouldn't be focused in one place, meaning there wouldn't be enough energy for the Big Bang to occur. Third, string theory has yet to be proven. It remains a work in progress and isn't a complete theory yet. So let's consider a couple more. One interesting idea is that our universe might actually be a part of a larger multiverse. There are a number of ways this could happen. The most popular is the many worlds interpretation of quantum mechanics, which states that every time a quantum event occurs, the universe splits into multiple copies, each representing a different outcome. Another way this could happen is through eternal inflation, which suggests that new universes are constantly being created out of quantum fluctuations in the inflaton field. This could lead to an infinite number of universes, each with different physical constants. Some people think that these theories are too speculative to be considered real science. However, that hasn't stopped researchers from trying to find evidence for them. One team of physicists, for example, recently claimed to have found evidence for a parallel universe in data from the Large Hadron Collider. Of course, this claim has been met with skepticism from the wider scientific community, but it illustrates the lengths that scientists are willing to go to in order to solve this problem. Ultimately, the question of what came before the Big Bang may never be answered. We may never know for sure what happened during those first few moments after the universe began. However, we can continue to search for answers. By studying the CMB and other evidence left over from the early universe, we can learn more about how it began and what it was like in those first few moments. And who knows, maybe one day we'll find the answer to this age-old question. If you enjoyed this video, please make sure to subscribe. If you want to learn more about string theory, check out my latest video on string theory. Thanks for watching.